Does Planet 9 exist, or is it just a myth? Guess what? We found the elusive Planet 9. But hold on, are we facing the threat of a gigantic celestial body? Is this the mythical Nibiru? Recently, I've seen a surge of clickbait news claiming we've found Planet 9 or that it's somehow threatening Earth. Many of these stories recycle the same old hypothetical scenarios, some rooted in science, but a lot purely speculative. While we haven't yet confirmed the existence of Planet 9, the quest for it has led us to some genuinely fascinating scientific discoveries that often fly under the radar. Research suggests that not just one, but potentially up to 200 planets could be drifting in the icy outskirts of our solar system. Some of these objects are so peculiar that scientists are still scratching their heads trying to understand them. So, where does the search for Planet 9 stand? What's truly lurking at the edge of our solar system? The concept of an extra planet orbiting our sun has ancient roots dating back to the Babylonians. They were remarkable astronomers who even theorized the existence of celestial bodies they couldn't see, including what's now referred to as Nibiru. However, in the 1970s, a writer named Zecharia Sitchin transformed Nibiru from a star into a planet, claiming it approaches the sun and causes disasters on Earth. This is, of course, pseudoscience. Nevertheless, actual scientists have reignited interest in the idea of a hidden planet in our solar system. Astronomers Scott Shepard and Chad Trujillo have been studying trans-Neptunian objects, small bodies beyond Neptune, and noticed that their unusual orbits suggest the gravitational influence of a large undiscovered planet. In 2016, astronomers Konstantin Batygin and Michael Brown observed that 6 distant Kuiper Belt objects exhibit strange elliptical orbits that seem to be aligned due to the presence of a massive gravitational force. The odds of this alignment occurring by chance are a mere 0.2%. The orbits of these bodies are also significantly tilted, around 30 degrees from the ecliptic plane. Batygin and Brown hypothesized that this could be due to a massive planet, potentially about 5 to 10 times the mass of Earth and situated between 400 to 800 astronomical units from the Sun. 1 astronomical unit is the distance from the Earth to the Sun, which is about 93 million miles, or 150 million kilometers. Thus, we would be looking at an incredibly cold, distant world. The orbit of such a planet could explain the clustering of trans-Neptunian objects. To search for Planet 9, astronomers use computer simulations that model the positions and movements of these outer solar system objects over billions of years, applying various parameters for the potential planet's characteristics. So far, researchers have scanned 87% of the sky where the planet is likely to be found, scrutinizing over 3,500 candidates, but none fit the bill of being substantial enough. So, why has locating Planet 9 proven to be so difficult? One major reason is its distance from the Sun. Even large objects can appear almost invisible at 800 AU. If it's out there, it's likely dark, freezing cold, and lacking any emitted radiation, making it challenging to spot with even our most advanced telescopes. For comparison, Pluto is 20 times closer to us, yet looks like a smudge in telescope images, only recently captured in detail by NASA's New Horizons mission. The challenge of finding Planet 9 has led to alternate theories, including one proposed in 2019 by astrophysicist James Unwin. He and his team suggested that instead of a planet, what we might be missing is a primordial black hole. These black holes are theorized to have formed shortly after the Big Bang, and many could be relatively small. For example, a black hole with a mass 5 times that of Earth would be no larger than a tennis ball. It would exert gravitational effects like a planet but be nearly impossible to detect unless it interacted with nearby matter. In his work, Stephen Hawking noted that black holes are not perfectly black. They can emit a faint radiation, but catching this light is nearly impossible. Moreover, the smaller the black hole, the faster it evaporates, making it unlikely that a primordial black hole could have existed for billions of years within our solar system. In the quest for Planet 9, astronomers have stumbled upon some astonishing findings that challenge our understanding of the solar system. It seems there could be as many as 200 dwarf planets lurking in the Kuiper Belt, but these aren't like Earth or Mercury. They don't have enough mass to clear their orbits. Pluto is a prime example of this, as it crosses Neptune's orbit and is thus classified as a dwarf planet. Dwarf planets like Haumea, which is notable for a rapid rotation period of just 4 hours, have been discovered. Haumea also possesses rings, a characteristic typically seen in gas giants. Its unique shape is a consequence of its fast spin, which causes it to take on an elongated form. Moreover, recent data from the James Webb Space Telescope has revealed that other dwarf planets such as Eris and Makemake could have geothermal activity capable of supporting subsurface liquid oceans, which raises the tantalizing possibility of life existing on these distant worlds. While some Kuiper Belt objects have perplexing trajectories, like Nibiru, which orbits the Sun in the opposite direction of most planets, these odd behaviors may not point to a hidden giant, but rather to the gravitational influence of a passing star, or maybe even the gravitational effects of multiple smaller bodies. On January 1, 2019, the NASA probe New Horizons visited a distant Kuiper Belt object named 2014 MU69, which later became known as Arakoth. It's a unique structure consisting of two lobes that appear to have fused together gently, a phenomenon requiring specific trajectories and gravitational interactions. The Kuiper Belt is a trove of mysteries, and not only could dwarf planets like Haumea, Makemake, and Eris provide profound insights, but they may also help us unravel the mystery of Planet 9. Some astronomers argue that the peculiar clustering of trans-Neptunian objects is a product of observational bias rather than evidence of an unknown planet. In 2021, a team of astronomers led by Kevin Napier suggested that the apparent clustering of these objects could be the result of observational limitations, leading them to believe that no new planet is necessary to explain their distribution. However, Brown and Batygin remain firm in their stance, supporting the Planet 9 hypothesis. Interestingly, some researchers are venturing into even wilder territory. A group of German astronomers led by Susanne Folsner proposed that the unusual behaviors of these distant Kuiper Belt objects might be due to gravitational interactions from a nearby star that passed through our solar neighborhood billions of years ago, rather than the gravitational influence of a large planet. The Kuiper Belt reveals a fascinating assortment of anomalies. Even as we continue to search for Planet 9, we may discover new celestial wonders along the way. And while the odds of encountering advanced alien civilizations on rogue planets are minimal, these celestial wanderers present a tantalizing prospect for future exploration. In the end, whether Planet 9 turns out to be a massive celestial body, a black hole, or even an aggregate of smaller objects in the Kuiper Belt, we remain on the brink of extraordinary discoveries. Scientists believe our understanding of the solar system is still evolving, and who knows what further revelations await us in the far reaches of space.